Hello everyone. The notes in this video will cover section 2.6 dealing with absolute value equations. Now, what are absolute value equations? The absolute value, first of all, it is the distance that a number is from zero on the number line. In the graphs in front of you, you see a point at -2, a point at +3, and the graph on the right. So if you're asked to find the absolute value of -2, you want to plot that point -2 on a number line and determine how many units away from zero that number is. In this case, we can see clearly that the -2 is 2 units from zero. Therefore, 2 is the absolute value. That's the answer. The distance that -2 is from zero is 2 units away from zero. So the absolute value of -2 equals 2. Now, similarly, if we're asked to find the absolute value of 3, we would plot 3 on a number line and we count the distance from zero. That's 1, 2, 3 units away. Therefore, the absolute value of -3 would be 3. Now, in this section, we're going to focus on solving equations dealing with absolute value. Now, here's some example of absolute value equations. We have the absolute value of x equals 3. We have -5 equals the absolute value of 2y plus 7. And then we have the absolute value of z minus 6.7 equals the absolute value of 3z plus 1.2. These are just some examples of absolute value equations. Now, when we are solving absolute value equations, we have to first determine the right form, okay? Understand that in calculating absolute value, we again measure the distance that the value is from zero. However, what if we have a negative or a positive number? What if we have a differentiation there? Let's say we have the absolute value of -4 and the absolute value of +4. So -4, what would the absolute value of -4 be versus +4? The distance that -4 is from zero on the number line, that's 4 units away, right? So the absolute value of -4 would be +4. What is that absolute value of +4? How many units away from zero is +4? Again, it's 4 units. What you notice is that the absolute value of -4 and +4 give you the same result. It's +4. Therefore, we don't know if our term underneath this absolute value symbol is negative or positive. So there's two possible answers. And the way that we solve these absolute value equations is we take those terms that are underneath the absolute value, in this case x, and we would set that value x equal to positive a, or it could be equal to negative a. Reason being, because we don't know if that number underneath is negative or positive, like in this example before, because both the absolute value of -4 and the absolute value of +4 gave us 4 as our answer. Therefore, to cover our bases, we take the terms that are underneath the absolute value, we set it equal to positive or negative. And we're going to look at some examples so you'll know how to work these out. Example 1, we have the absolute value of 5w plus 3 equals 7. Now, what are we going to do here? Just like we said before, we're going to take these terms that are underneath the absolute value, so 5w plus 3, and we're going to set it equal to +7, or could be equivalent to -7. So we have two separate equations to solve. We take what's underneath, so 5w plus 3, we set it equal to +7 or -7, and then we're going to solve. So begin solving by subtracting 3 from both sides of the equation. So -3 from both equations. And the equation on the left, we get 5w, we carry down our 5w, and 7 minus 3 gives us 4. We divide both sides of the equation by 5, and we'll get W equals 4/5. On the right side, we carry down our 5W, and then negative 7 minus 3 gives us negative 10. We divide both sides by 5, so W equals negative 2. So these are our two possible solutions. W could be 4/5 or negative 2. Now, you try this example. I'm going to pause for a couple of seconds. I want you to write down this problem, look at your steps from the previous example, and see if you can solve this problem before we go to the answer. All right, so in solving these problems, remember you start by taking the terms that are underneath the absolute value, so 2x minus 3, and we want to set them equal to positive 5 or negative 5. And then we're just going to solve both of these equations. So we're going to add 3 to both sides of the equations, and then we're going to divide by 2. So in our equation on the left side, we'll get x equals 4, or on the right, we get x equals negative 1. So we added our 3 on the right. We got negative 2 divided by 2 is how we got negative 1. We added our 3 with the equation on the left. 5 plus 3 gave us 8, divided by 2 gives us 4. Look at the next example. Now we have the absolute value of x over 2 minus 1 equals 11. We're still going to take those terms that are underneath the absolute value, set them equal to positive 11 or negative 11. We're going to solve the equation. We need to determine the value of x. So we're going to add 1 to both sides of these equations. Add 1, add 1. We'll carry down our x over 2. X over 2 on the left side, this left equation, 11 plus 1 gives us 12. Adding 1 to the equation on the right, negative 11 plus 1 gives us negative 10. Now we need to get rid of this denominator of 2. We're dividing by 2. The opposite would be to multiply by 2. So this is what we're seeing here. We're multiplying both sides of the equation by 2. When we multiply both sides of the equation by 2, the 2's will cancel, leaving x. So we have x on the left side of the equation equals 2 times 12, or 24 on the right side of the equal sign here. Now in our equation over here on the right side, the 2's will cancel. We carry down our x, and that equals 2 times negative 10, or negative 20. So our two solutions, x equals 24 or negative 20. All right, another example. Now this problem looks a tad bit different from the other problems. We have the absolute value of 2x plus 5, that's an added term, equals 7. So the first thing we got to do is we have to isolate this absolute value of 2x. We need to get 2x by itself. So we're going to subtract 5 from both sides of the equation first. Now, when we subtract 5 from both sides of this equation, the 5's will cancel on the left, leaving 2x. Equals, on the right side, 7 minus 5, we get 2. Now we'll proceed with the steps from before. So we're taking the terms that are underneath the absolute value, 2x, and we set 2x equal to positive 2 or negative 2, and solve the equation by dividing both sides of both equations by 2. So x equals 1 or negative 1 are our two solutions. All right, Let's take a couple of seconds, try this example. We want to isolate our absolute value and solve for x. All right, so in isolating our absolute value, we subtract 1 from both sides of the equation. And that leaves us with the absolute value of x minus 3 equals 8. Now we'll take those terms underneath the absolute value, the x minus 3, set it equal to 8 or negative 8, and solve by adding 3 to both sides of the equations. And we'll get x equals 11 or negative 5 as our solutions. All right, let's look at another example. Similar to the last problem, we need to isolate this absolute value. So we're going to subtract 18 from both sides of the equation first. When we subtract 18, we're left with the absolute value of 9n plus 8 equals negative 11. And now we can stop here because we just talked about what the absolute value means, right? That absolute value symbol measures the distance that 9n plus 8 is from 0 on the number line. Absolute value can never be negative because distance is not negative. There's no such thing as negative 11 feet. Distance will always be a positive number. So for this problem, if you get absolute value by itself and it equals a negative number, you would write no solution because the absolute value can't be negative. All right, so that was the last example from our notes. So we'll stop here for notes for 2.6, absolute value equations.